Hey Al, here's an update on the progress of my new toolkit for Godot. It's a plugin that integrates all of your projects directly to SQLite. So what are we seeing on the screen right now is a small little test project that is streaming 10,000 NPCs onto the heat map component. So here I'm pushing the heat map component to have 10,000 stickers and updating live their positions. Here is the grid with 10,000 rows very responsibly being refreshed every second, pulling directly from the database. So if I undo the refresher so we can see for a second, I can easily sort 10,000 records. And this project, although the FPS, if you notice at the bottom, is quite low right now, that is mostly the main thread having a really hard time updating each object's positions. So until now, I've been pushing the component to as far as I can tell. It's still like it pulls. Right now, it's doing every single one of these objects are actually posting write calls to this component and is writing their positions to the database. And this component here is actually pulling the refreshed positions directly from the database. So this is a grid that is loaded every second with 10,000 rows. So let's go see a bit what's going on here. So in this, we have our main component, which is the plugins. So we have data visualization tool that's been already released on itch.io, and that has all of the charts and the visualization tools. The counterpart to that I've been working on for the last couple of months is the DataWizard, which once you install this, it installs another global component, and that allows you to directly connect and generate a database on the fly. So however you're saving your files for your players, you simply have to tell on open, you tell it where you want to save this database, how many threads that you want, because yes, this is multi-threaded SQLite. You have a dedicated thread that receives thousands of write calls per second on a main thread. It batches them together, commits them all together, super efficient. And then we have on the side, which is what this component, this parent parameter controls here, is how many read connections would you like to have. So right now I have 12 because I was just trying to see if it makes any difference in performance wise. 4 seems to work really well. And so right now, this is all you need to do to create the database. Then how do you get tables in there? So here, my enemy that I'm using to generate 10,000 data points, all you need to do is go into your existing project and convert any resource type class from extending resources to a DW record. So the DW record is it extends itself from resource. And then by giving it a couple of basic, this is all of course going to be documented just like my other data visualization tool. Once it's been released, you give it a couple of basic parameters of like what is the table name in the back end. There's going to be some really neat table types, which is subject to change, but some audit log tables that automatically are just going to take in and auto generate a key. You have to use scratch tables that automatically clean themselves up when the game unloads, so it's great for debugging and whatnot. So on this, you tell it what your primary key is, so that it knows all this is managed by upserts. So the objects, once they're instanced, they can just keep pinging and updating themselves to the database, and it's never going to have kind of like the duplication of data. So it'll take whatever properties that you have in this class, and it's automatically going to serialize them. To give you an idea of the extent that I've been testing this out, every single type of variable and object has been vetted out, and in this test case, it goes through. One saves the this particular NPC to the database, and then compares itself to a JSON structure, which is up here. And, so it validates itself, and then if it passes all the tests, then it lets me know, yeah, what you've been able to serialize and then rehydrate this object. We also have the ability to have nested records. So this player not only is saving its ID and name, but also has a secondary class that is stored in a secondary table for attributes. So all of this is saved and reloaded within the parent object. So you can have as many nested objects as you want. Everything is automatic. So you don't have to worry about, like, how do I create the table properly? How do I do the indexing? You can even have some advanced stuff, like if you want something to happen to your object once after it loads. So maybe you're just connecting your signals and whatnot, so you can do all of that. Anyway, let's go back to the demonstration, because this was supposed to be a simple demonstration. In the main, what are we doing? So the first thing I did was I created, if I find my create enemies, we have 10,000 enemies being generated with a simple little loop, and at the end of each of the creations is saving it to the database. Then we have on ready, we have we're loading it from the database. That looks very simple. This is an array, and you simply do select, you pass in the class name, and there's a couple of, these are optional parameters. You can provide a where clause, so like give me all enemies that are still alive, or give me all enemies in a certain area, whatnot. And then that just fills array. It's super fast to put it in. And then you can, here's the code that loads the grid. The grid, I wanted to test out the pure queries. So here you have the full power of SQLite directly at your fingertips. So this is where it starts to get really interesting, because it's fine to have individual resource files, and it's saving that file, that class, directly to a table, each instance to a table record. But the real power comes in where you have the ability to write complex queries that pull from multiple places at once. So then you can start saying things like, give me the last 25 transactions for the last 30 days that these two enemies interacted with each other. So the sky's the limit. If you know anything about SQL, you can put all those joins and whatnot. And with this query, it returns whatever you wanted in an array of dictionaries. So that's super. It uses the variants from Godot, and you can populate that. So this is how every second it's getting pulled directly from the database and pushes that into the UI grid that we're seeing with the updated positions. The rest of this code is really just async with some threading up here. So we have multi-threading here that goes through and tries to alleviate the main thread's load, just because we're updating 10,000 positions, every couple of milliseconds. So all of this to say here, this has just been a wild ride of trying to automatically serialize and generate a schema based on the table structure or the class structure that you have in your project. So it's really getting close to production ready, and I absolutely needed something as versatile and performant as this for my own game, because it's a full city simulation sandbox game that has thousands and thousands of NPCs. Each of those have multiple systems in play, and I need to log every little thing that goes on in order to, one, debug, and also provide really interesting emergent content for the game. So this is really promising, and hopefully it gets some people excited as much as I am, just to be able to have a actual relational database inside of your projects and all of that power that entails. So, all right, thank you very much, and I'll be sure to have a update in the coming weeks on the actual release of the product. But until now, this is where I'm at.